now live on YouTube for our 35 or the 35th Everyone Can Contribute Cafe. And today we are not breaking something on purpose, but we are actually doing something around chaos and some chaos engineering. And I'm super happy that we have our friends from Litmus over here and showcasing us or like teaching us what is new, what is coming in chaos engineering, what it is, why we want to use it, and many more insights. I've had a little peek already, but I don't want to spoil you. I just want to hand it over to Kartik and Prithvi. Just go ahead and share some news, please.
Sure, Michael. Thank you so much for introducing us, and thank you so much for inviting us to this Everyone Can Contribute show. I think we are really glad to be a part of it, and I mean it's going to be an experience altogether with the cloud native world coming so far and chaos engineering as a technology coming so far. I think it'll be an honor to present in front of the audience. And before I present anything, I think I would just like to talk a little bit about how this journey has come together and how the community has responded to it. So back when I started last year, the amount of users towards cloud native chaos engineering were pretty less. I think we had a community of 40 to 50 members, and chaos engineering adoption was taking a peak, but I think the cloud native chaos engineering segment was still having a low amount of users or was not getting that amount of attraction. But today, when a few days ago, I just saw 100,000 installations, and I saw a lot of folks taking keen interest even in the community, or if you talk about the events that are happening, the support from CNCF, KubeCon, and all these things, then I think today I can claim that chaos engineering as a technology has come really far and has been an interest of many, not just SREs, but initially we thought it is an interest of just SRE, the SRE persona, the testing, the ones who are testing are looking at chaos, but today even developers, everyone, even the ones who are building are taking a closer look at chaos. So with this, perhaps I would like to start off the presentation I have in hand, and perhaps I'll share my screen. So is my screen visible to everyone? It is, right? Thanks. So we'll be starting off, as you can see, the presentation on hand is introducing Litmus Chaos, Cloud Native Chaos Engineering, and we are glad to be a part of the GitLab. Everyone can contribute. I hope the folks who are joining in will have a good run through this presentation and the demos that we have. So starting off, I'll just introduce myself. My name is Prithvi Raj, and I am working as a community manager at Chaos Native. It just spun off from a company called Maya Data, and I was back in Maya Data since last year, working as a community manager for this Litmus Chaos project, which is, as you know, a CNCF sandbox project. And alongside that, I work as an event organizer or co-organizer of these meetups and events. As you can see, Chaos Carnival, an event based on chaos engineering. I mean, chaos engineering has grown so much that there's an event around it, and a lot of folks, starting from Red Hat to Intuit to so many folks from around the world, around different companies, came in and talked about various chaos engineering use cases. And then we have our chaos engineering meetups, which happen every last Saturday of the month. So folks who want to join in can come in and join in the chaos engineering meetups. We pretty much have an informal session or have some agenda items, and then take up Q&As and try and bring in this journey of chaos engineering adoption further. And then there's Kubernetes Community Days happening this Saturday, the Bangalore edition. So anyone wants to join in. Kubernetes again is seeing the adoption at such a level where even chaos engineering hasn't yet. So where Kubernetes has crossed the chasm for major market adoption, chaos engineering is still coming up. So moving on, the agenda that we have in hand today, I mean, there are a lot of things we'll be talking about, but starting off, we'll be introducing chaos. You can ask your questions, you can put your questions in the stream chat as well. And then we'll move on to cloud native chaos engineering and then introduce Litmus to you, what exactly Litmus is. And then move on to the fun stuff, which will be taken forward by Karthik, who will be talking about the architecture and giving you the live demo and how we evolved to 2.0, which is due to release in a few days. And lastly, obviously, everyone is invited to contribute. It's an open source project, so contributions are welcome. So we'll move on to that. So what is chaos engineering? That's what you all wanted to learn. What is chaos and how did it come up? So I'll just start with the story and then perhaps I'll move on to what chaos engineering is. So in India or around the world, there's this Black Friday sale around the world. Or in India we have Great Indian festivals or big billion day sales. These are huge sales organized by Flipkart or Amazon, these companies. And what we noticed was when I was not introduced to chaos, what chaos is, I used to wonder how these spikes are actually causing an outage. What exactly is an outage, and why are resiliency goals not being met in spite of so much being spent on quality and assurance, penetration, so white box, black box, so many types of testing is around there. But still, why is this one factor which is not available to meet these resiliency goals? Why is these outages still occurring? There's a spike of users and these applications used to go down. And it's not just about these applications. Any application, any system has the potential to go down. It's just about time. We know that someday or the other an application has to go down. It's just when does it go down and how can we prevent that? So that is how this comes into play, and that is how the term chaos engineering came into play back in 2011, 2012 when Netflix brought into play. The idea of bringing in something into the system to prevent an outage. What is it? We'll talk about it. But moving on, let's just not talk about the spike in users. But what does it cause exactly? Downtimes. Chaos engineering causes downtimes. Your system goes down, and there's not just loss of time, but there's loss of money as well. I mean, billions and billions of dollars are lost for a huge enterprise if the system goes down due to a spike in users or due to some outage that happens. And this is where chaos engineering came into play. Netflix thought that when they're having a spike of users, when suddenly there's some show, some series that comes up, and they need to scale, they need to understand the value of scalability with legacy systems moving into the microservices world, or even for legacy systems itself, it was pretty essential to actually understand how these are functioning. So downtimes are expensive, and that is where chaos engineering came into play. What chaos engineering is nothing but inducing an outage in the system deliberately in a controlled way so that you understand what a future vulnerability or an outage can be. How exactly your system reacts when there's a future actual outage in production. And when the system goes in production, that is where the DevOps feedback loop is activated. That is where you understand that you have to do proactive testing in production. I'm not saying that it starts with production, but eventually the goal is to achieve resiliency when your system goes into production. So test, don't wait. This is something which we learned through the chaos first principle. Now, a lot of people ask, what is the chaos first principle? The chaos first principle is nothing but why to wait for an outage? Why not test first? So test your systems first before moving into production. That is how chaos engineering came into play. So what has been the state of chaos engineering till as of now? I mean, there are standard practices that exist. It started all of this started with Chaos Monkey, but it's still limited. Not everyone is practicing chaos. Not everyone has moved on to practice chaos and what exactly chaos engineering is. Still, the amount of unawareness that is out there is something which is, I mean, mind-boggling for me. But it's very important for you to understand how to start chaos engineering practices. Or this is very important. This should not just be limited to experts or large deployments, but this should come as a practice for each and every one who's looking forward to resiliency. So as of now, those who have burned their hands, those who have gone through an outage, for them, chaos engineering has been a resolution. And you can see a lot of folks from Amazon to Netflix to Disney, HBO, these folks have started working on chaos already. There are some chaos engineering stories already out there from them. So how is it done typically? Usually it's done in some these ways, but this is not what it should be limited to. This is not what it should be, just should be the ways to follow chaos. I mean, they are done through chaos engineering game days. Usually there's a game day where one of the applications is, chaos experiments are run in one of the applications, and a few chaos tests are carried out to see how the application reacts. It can be specific to the company, it can be specific to the use case, and basically this is how usually the chaos engineering experiments are done. And then it's rarely integrated to the CI or the CD of your system. It's I mean, everyone hasn't even thought about chaos in your CI CD. Why not? I mean, chaos can be anywhere. It can be in your CI/CD, it can be in your developers environment, it can be in your pre-staging, staging, production environment. So chaos engineering has to come in everywhere in some form or the other. As I said before the start of the presentation, that only SREs are focusing on chaos as of now. The developer persona is still not adopted chaos in a huge way. Everyone has not adopted or engaged in chaos, in practicing chaos engineering, but slowly it's coming up. And I mean, there's a manual planning and execution that is going on, but you have to understand that chaos engineering is also a part of automation. I mean, with systems getting automated, I think you'll be able to run automated chaos as well. That's the goal eventually. So the manual planning and execution is good, but slowly you need to move on towards the automated way of doing it, where you can schedule them, you can create workflows, you can see how various chaos tests together function. And observability is key. I mean, you have to see what is happening to your system, right? It's not a commodity. It is actually every enterprise or everyone has to see what is going down, what is going up, and how is your system being affected when a chaos test is induced. And lastly, I mean, there are a lot of things to see your results and how they increase your reliability. I mean, there's a custom measurement process to managing all these things, but the typical way needs to change. That is what the agenda is of talking about all these things. I mean, that these typical practices are good. I think the adoption which has come in has been good, but this typical way has to change. I mean, more and more tests need to be curated, and you need to create more and more use cases. I mean, write your own experiments, think about the system, and it should come out in the community as well. I think this event talks about that. I mean, such streams and such events are very important. So what are the benefits? What exactly are the benefits of chaos engineering? I mean, the first and foremost is you run your services without an outage. I mean, chaos tests help you, and you test repeatedly. It is a process. It just doesn't happen once. You test repeatedly. What happens is you need to understand the steady state of your system. What exactly is the steady state, and how does it function? And then you need to run your services without an outage. You need to actually take a look at repeated testing. So I'll just perhaps take you through. Just give me a sec. I'll take you through something which shows how it is tested, basically a workflow. So just give me a second. Yeah. So if my screen is visible to you all, you can see that chaos engineering why. I mean, this is an example of a Kubernetes application that, as you can see, that there are various, I mean, it's a pyramid. It's like a pyramid. There's an application you have, and then there are other services as well running alongside that. It can be in MongoDB, or I mean, in the cloud native world, you run all these applications like Kafka, TIKV, Vitess, and all these applications, and then come the services which, Core DNS, Envoy, Prometheus to get your metrics, or databases, OpenEBS is one example. Then there are Kubernetes services in a chaos engineering, in an application, and then come the platform services. So it's like a pyramid, right? It's not just your application, but there are various layers which are also functioning alongside that. So what is very important is that each layer should, the resiliency of each layer should be maintained. Each layer should be tested so that all the components and infrastructure are strong. All the components and infrastructure become reliable, because resiliency doesn't just depend on one, but it depends on all the components. And how is it done? So basically, if you can see, you identify the steady state. You identify what is the steady state of your system. This diagram has gone haywire. I don't know why. And then you introduce a fault. You introduce one test. It can be anything. For example, just giving an example, in a Kubernetes application, it can be a pod delete. So you introduce a pod delete experiment, and then you see if the steady state conditions are regained or not. These are part of the principles. The principles of chaos tell you that first you have to identify what are the steady state conditions of your system. And if the steady state conditions are regained, then yes, your system is resilient. But you go on testing. It's not a single step process. Then you inject a new fault. It can be a pod CPU hog. Just another example, that if a pod delete experiment works, then you induce another fault to identify the steady state conditions. And no, if your system is not resilient, then there's a weakness found, you fix it, and then you again introduce a fault. And this is a process which continues going on. This is a repeated step, and because you never know when in an outage occurs. So this is how a chaos engineering. This is basically a diagrammatic representation of the principles of how your system gets resilient with chaos being induced into your system. So moving on, moving on, what are the benefits of chaos engineering? You run your systems without an outage. And then SLAs and SLOs, service level objectives and service level, agreements, and all these things are very, very important to run your services, to meet your business goals or to meet your individual goals. We just had an SLO conf. SLOs have become so important, and that, everyone is thinking about it. So chaos engineering and SLOs go hand in hand, and you are able to meet your business level SLAs and SLOs by running these chaos tests. And then scalability, as I talked about, your services are scaled according to these tests. These tests help you understand the resiliency, and that is how you scale your services and on demand, and then upgrade them according to your requirement, however you want, adding more systems to it, and doing it without an outage. That is what the benefit of chaos is, and why we talk about it. As of now, there are a lot of projects. As you can see, these are the projects out there. There's Gremlin, there's VMware Mangle, and then some open source projects as well, like Chaos Mesh, Chaos Plate, Cube Invaders, Chaos Cube, and then also on the enterprise side of things also there. It's a trending technology. CNCF has called it one of the top 5 technologies to look forward to in 2021. And with all these projects coming out, I think the options are pretty, there are a lot of options out there, and then the chaos engineering ecosystem is completely developing. So why exactly, chaos engineering has been given so much focus to is because reliability is a budding challenge. And where does chaos engineering come into play in these container level challenges? I think all of them has some amount of role for chaos to play. Complexity, of course, chaos engineering helps come into understand where your system is getting complex. Then security challenges, again, there are 32% security challenges. If you talk about reliability, there again 12% are reliability container level challenges. So I think, and cultural changes. I think one thing is we just conducted a survey recently, and people talked about a lot of challenges they face, and that was all part of cultural challenges. Someone doesn't have observability in place, its chaos is not in their roadmap, or their systems are not ready, they have not migrated, some or the other. The higher level authorities are not ready yet, or the ecosystem is not fitting their systems. So these are the challenges. But as you can see, I mean, according to the trends and predictions, chaos is the future. Chaos is something which everyone should adopt. And moving on to how did Litmus come into play, or when we started Litmus, it was all about Kubernetes. And I mean, Kubernetes needs a resilient tool set because every day there are changes, and traditional chaos engineering tool sets that are out there do not really suit the Kubernetes way of doing it, because that's a persona, right? And what are the driving factors? Continuous verification, chaos engineering your platforms, and as I said, SLOs for your CD. And these are also recommended by the SIG app delivery, or the tag app delivery as it's known now in the CNCF. It's a working group, and chaos engineering is one of the vital projects that they have been focusing on. So what is cloud native chaos? I mean, Karthik will be explaining a lot more about it with Litmus, but I'm just going to point out a few principles in our belief that are part of cloud native chaos engineering. So according to us, I mean, there are a lot of principles of chaos, and I mean, the majority of them are mentioned at a website called principlesofchaosengineering.org. I'll perhaps forward the link here as well. So as you can see, principles of chaos engineering are already out there, and it's an open source repo, I think, where he has put up the principles. And these are the major principles. You build a hypothesis around your steady state, as I mentioned, and then you vary your real world events, run experiments in production, and then automate them. So that is how it continues. And lastly, you minimize your blast radius while you continue experimenting in production. These are the basic principles of chaos engineering. But what are the principles of cloud native chaos? That is what we came up with while developing Litmus. So these, as you can see on your screen, it has to be open source, community collaborated, open API and lifecycle management. GitOps is something which is coming up in a huge way. I mean, you need scalability, and the GitOps integration is must, and then observability. So while we move ahead with the demo and while we present you, we'll go in depth into all these principles of cloud native chaos engineering and how they build the foundation of it, how they came up, and that will be explained by Karthik. But these are the principles mostly which was followed in Litmus as well. So moving on to what Litmus is, I mean, this was the best time to introduce Litmus. Litmus is nothing but an open source tool set, part of the CNCF Sandbox Foundation, which is used to practice these chaos engineering practices in a cloud native environment. Just not limited to Kubernetes, by the way, in case you're thinking it's just limited to Kubernetes. It's also, I think, I mean, with the community demands coming in, it's more than Kubernetes for AWS, or I mean Azure, and all your non-KTS scenarios as well. Litmus comes into play in a very huge way with various experiments. And obviously, while I talk about the features it provides, I think you'll get some more idea on it. So as of now, I mean, there are 58 chaos experiments. You can find them on the Chaos Hub. Karthik will take you through the Chaos Hub, and these are a few stats. I think, as I mentioned, it helps you identify weaknesses and potential outages by inducing chaos in a controlled way. And Litmus is the early leader. I mean, the amount of adoption we have seen and the amount of use cases that have come up with Litmus, if you talk about the banking sector, e-commerce sector, or any fintech sector, there have been various use cases which have come up and have helped this Litmus community develop. So just a little bit about the history of the project. It was, I mean, we founded it late in 2017, early 2018, while testing another project which we were working on, that was OpenEBS. OpenEBS is a project based on cloud native databases, and there we thought that we need a tool set to actually find out our resiliency goals. We needed chaos testing back then itself to find out, and we started writing out just a chaos testing. I mean, we started writing out our own code and thought that we can write our own chaos engineering toolset, and we never knew that today it'll become this big and it'll come so far. But yeah, I mean, that's the history and the project status of it, and talking about one of the features, as I mentioned, that it's not just about chaos engineer, KATS scenarios. One is obviously it's possible to test your systems in non-Kubernetes scenarios as well. And the second thing obviously is there's a very nice feature that Litmus provides is bring your own chaos. That is, you can write your own chaos experiment with the Litmus SDK. So you just don't have to depend upon the chaos hub where all the chaos experiments are present, but you can write your own experiment and induce chaos in your systems with Litmus. So we'll talk about it more. I mean, that was it from my side to give you an overview of what chaos is and how Litmus came into play and what Litmus is. And perhaps I'll be open to any questions if are there, and then Karthik can take it forward. I see a couple of things in chat. Okay. Yeah, so are there any questions for me?
Can you maybe share the URL to the Litmus SDK? Is it the Litmus Go repository on GitHub?
Yes. It's the Litmus Go repository on GitHub. I mean,
okay.
Most of our experiments are written in Go. I think some of them are written in Python as well. But yeah, it's the Litmus Go repository where you can check out how.
Perfect, because I want to share it in the Twitter thread I'm currently doing, and you can just go ahead. No further questions from my side. Thanks.
Thanks a lot. Thanks a lot, everyone. I think my Karthik can share his screen and get started.
All right. Thanks, Prithvi. Thanks, Michael. Let me go ahead and share my screen. I hope my screen is visible.
Yes.
Okay.
Yes,
yeah, let me introduce myself. I'm Karthik, one of the maintainers of the Litmus project. And I've been having a blast really trying to contribute to this project and maintaining it. Great community interactions like Prithvi was mentioning. So what we'll do as part of this segment of this session is we'll try to go through the basic architecture of Litmus, and the Litmus version that is being used by folks all over is 1.x, that is 1.13.6, that's the version that's being used. There's also some efforts going on to come up with Litmus 2.0. It is an advanced beta right now, and it's being tested by some interested community members. So we'll talk about what caused us to evolve and transition to 2.0 and what are the new features. We'll pack in a couple of demos, one on the 1.x variant and then one on 2.0 as well. Before we proceed, I'd just like to recap what Prithvi was mentioning as part of his demonstration. He was basically telling how chaos engineering is generally done. And you start off by identifying your steady state conditions. How do you expect your application or infrastructure to behave when it is under optimal operational state? And then you inject a fault, right? And you check whether your steady state hypothesis is met. And this steady state hypothesis that you're checking can basically be anything. It could be a lot of parameters. You might want to see how much a particular performance metric has deviated. You might want to see how quickly your application or service recovers. That's also possible. So there are a lot of ways you can define hypothesis around steady state. And once you've checked whether that is met, then you go and qualify the application or service as being resilient to that fault. If not, then you would have found a weakness. So you go back to the drawing board and you fix the business application, or you might fix something in your deployment environment and essentially repeat the experiment and see whether things are as per expectation, and then move on to the next fault or the next resiliency test or experiment, as you would call it. So this is the typical flow. Now, why did we do this recap? Is because I wanted to introduce you to this new paradigm that has come about over the last 2-3 years. The cloud native way of doing things is all declarative. And when we say cloud native way of doing things, you can implicitly read it as or understand it as the Kubernetes way of doing things, because that is the predominant platform that is driving the cloud native innovation today. So everything on Kubernetes is declarative, and it is all dealing with resources and controllers mapped to those resources. Everything that you would do, right, in terms of defining infrastructure and cluster API and Tinkerbell and a lot of such projects today are defining how you can define cross-plane. Example, you can basically go ahead and define your entire infrastructure in a declarative way, and with the help of Kubernetes orchestrate the creation of infrastructure itself. And then the Kubernetes control plane components, or the system services as you would call it, or the applications or workloads that you put on Kubernetes, or the characteristics of those applications, such as security policies or resources. Everything is declarative. It is basically YAML, and it is reconciled. And when you're coming to resilience checks or resilience testing or chaos intent, you would want that also to conform or adhere to this user experience that people are having with Kubernetes. Prithvi talked about how Litmus was actually trying to, it was brought up for the resilience testing needs of OpenEBS. And OpenEBS, being another cloud native container attached storage solution, offered everything in terms of resources. So when we were trying to test OpenEBS and we were trying to get the users of OpenEBS to test their environments using Litmus, we were trying to give them that homogeneous experience and trying to put chaos intent in a declarative way. So apart from this huge dependency tree that you saw, the pyramid that Prithvi was explaining, where in case of Kubernetes, a dense environment contains your platform services and Kubernetes on top of that. And then you have all your tooling from your cloud native ecosystem that you're so dependent on to run your services successfully. Then you have your application dependencies, your database, storage, etc. And then you have your middleware and application services, front-end user-facing services. There are so many points of failures. So there is one reason of trying to do chaos. There's one more, good reason or more reasons for doing chaos in Kubernetes environments, and better done in pre-prod environments. And when you do that, you would like to do it in a cloud native way using a declarative approach. And I've just created some or mapped a couple of diagrams here. You can see that this process of identifying steady state conditions, introducing faults, etc., is now converted into resources and controllers that reconcile those resources, right? This part of the flow. And the checks whether the SLOs continue to be met, these are all burned into your experiment process, because many times you want to run your experiment in an automated way. And when you do that, you want these checks burned into your experiment flow. So there needs to be a way to define your steady state hypothesis or application validation also as part of your experiment in a declarative way, not just the fault. And then you go ahead and put all that information inside of a resource, which you can consume in an easy way in another CR, and you basically go ahead and generate useful reports. So that's what we try to do with Litmus. And at the heart of Litmus are some chaos resources. We will take a look at them as we do our demonstration in a second. Chaos experiment is a template. It is pre-built. It contains granular definition of your chaos intent. And the experiments run as Kubernetes jobs, like I was trying to say. And all the Kubernetes chaos experiments, the templates are available in this chaos hub. You can pull them, right? And there are categories defined here. Generic are the ones which consist of most of the experiments that you would do on a day-to-day basis on standard Kubernetes. There are other application-specific experiments here, which are faults combined with native checks for those experiments, for those applications. And you can pull chaos experiments from there, and then you create chaos engines, which are user-defined. mostly the how part of chaos experiment. You bind your application instance with a fault. And this is the bridge which actually binds a particular fault that's defined within an experiment. Here, the experiment resource with an application instance as defined by what namespace it is running in, what labels it can be identified by, and what kind it is, etc. You could also define the steady state hypothesis validation intent in this particular chaos engine. And this is the one that is active and reconciled by the chaos operator, which was written using operator SDK. And the chaos result holds information about your run process, what happened to your hypothesis intent, and what happened, what is the state of the test currently if it's a long running test, and what is the verdict of the experiment. The verdict here is something that is optionally consumed. If you are doing your experiments in a freestyle exploratory manner, you do not need to depend upon the verdicts that Litmus provides you so much. You have your own observation to make. But if you're running it in an automated way, you would like to know what happened to the experiment, whether the expectations were met or no. That's where the verdict is going to be useful. There are some other CRs, auxiliary ones like the schedule, which helps repeat experiments in a different in a schedule that you would like to see. You can define start or end time stamps, or you can define minimum chaos intervals. You can do it strictly scheduled or randomly, etc. So the flow of the Litmus 1.x is something like this. As a DevOps engineer or an SRE or a QA or a developer or whoever the persona is, you have your application on your cluster. You pull the experiment from the chaos hub. You create the chaos engine to apply this experiment against a particular application, or maybe some infra component like a disk or node on your cluster. And then you apply the chaos engine. The chaos operator is then going to create some child resources, the experiment runner and the job. The job is the actual unit of execution, or the one that carries out the business logic of chaos. And that eventually does the fault, hypothesis, validation, and then finally stores everything inside of a result. And the same thing here is represented in a block diagram. And let's go and take a look at how to do this as a demo. And
I ask one small question.
Sure.
How I would download or get experiments in an air-gapped environment?
Great question. So Litmus allows you to set up the hub in your own private repository. So you could just fork it as a private repository, or you could create these experiment YAMLs by yourself. They are very simple. You just let me show you how an experiment YAML looks like.
This was my second question.
All right. So yeah, the experiment CR looks like this. You have an image here that actually runs the chaos. As you can see, there's a spec.definition which holds information about what minimum permissions are necessary to run this experiment. It's just indicative, this particular part. The spec.permissions is basically, spec.definition.permissions is to just say what minimum permissions are necessary to run the experiment. You can create an RBAC using that information. There are some tooling on the Litmus side that can help you do that, but you could create it yourself. And then you could define how the job runs, what is the image that is going to be used, what's the pull policy, and there's some entry point here, and then some minimal environment variables provided. The bare minimum ones or necessary ones that are just enough to carry out the chaos. The mandatory inputs are provided here, which you will eventually override from the chaos engine, because that's the instance thing. That's the dynamic entity that you're going to create on a per chaos basis. This is something that's global to the namespace, global at the namespace level, or you could put it at a cluster-wide level as well. So in case of air-gapped environments, you could have your own images coming from your own registries, and these CRs can be maintained in your own repositories. We just create a private fork of this repository called as chaos chart. Let me just show you that. The hub here is a canonical front end for what manifests are stored in the chaos chart. So you can just clone this. and maintain your own set. It's heavily inspired from operator frameworks, operator hub. So we have the experiments defined here in the respective folders inside the category. The generic category contains the experiment folders, and there is an experiment YAML that you can pull, and there's a recommended RBAC that you can use to run this experiment that is going to be consumed by the job that runs the experiment. And there's just some metadata files here to render the information that's on the Chaos Hub, all the metadata that you see within a card. So you could run this by pulling these manifests into your own repositories instead of your intranet if you're running in air-gapped environments, and getting the images from your own registries. Does that answer?
Yes, thank you. But then another question before we start. As I saw it, does the operator and this jobs it spawns, are they privileged? Do they need more rights? Because I saw some host, let's say, experiments. So are they privileged or?
Great question. So some of them are not. Some of these experiments use purely the Kube API, and just go ahead and run without needing to be privileged containers, if that's what you're asking. There are some experiments, for example, the ones that make use of some Linux utilities within the host or within the system to go ahead and inject network loss or stress chaos. For example, you're trying to simulate some resource exhaustion or resource chaos within a pod by running some stress processes. You're running some CPU burn or memory burn processes, or in case of network experiments, you're trying to create some egress packet loss. So to do that, we make use of the runtimes APIs, Containerd or Docker or CRI-O. And for that, we need to be living in the same node where your target application resides. And we will be injecting these processes, the chaos processes, into the network namespace of the target pod or the process namespace of those target containers. And in doing so, we need to be able to run them in a privileged manner. So that is a few of the experiments which do need privilege escalations for the jobs that run. Most of the others, the pod delete ones, or the node related experiments, the ones that are draining the nodes or causing eviction taints, things like that, don't really need the privileged services, privilege escalations. Does that also help?
Yes, cool. I mean, I really like it that it's, let's say, on-demand privileged when you need it and not like always. So thanks for the clarification.
Yeah, and since we're talking about the privilege escalations, one of the features, differentiating features of Litmus is the fact that, as you can see here in this architectural diagram, we run a job, and the job is going to run for a period of time as defined by you. Let's say it could be 60 seconds or 120 seconds, so for whatever duration you want the chaos to be active. And we are going to run pods with privilege escalations for just that period, rather than run something like a daemon set on your node, which is perennially running and carries all these Docker cap and privileges. So you probably restrict the amount of time that you're going to run it, which probably is one benefit that you would get with Litmus. We also try and recommend some pod security policies. There might be some gatekeeper policies that we might document in time, which might help you to create some security policies and create RBACs that just make use of that security policy and not use a service account that you might be using for some other purposes on your cluster, and thereby find means to minimize the impact of running something like this. So that's something we're consciously looking at in Litmus and trying to document as we go. Okay, coming back to the demonstration of Litmus 1.x, we're trying to go with the hello world process, so to say, in chaos. The pod delete is always, it's like the hello world program in chaos engineering, a very popular test. Pod delete, in the later part of this demo, if we have time, we can show how effective it can be by adding the right kind of intelligence into the experiment. So the deletion of the pod, so simple as it sounds, can unearth a lot of impact on the cluster or on the applications. So right now, I just have a GKE cluster with me as a single node cluster, and I'm going to install the operator. I've come to the Litmus docs.litmuschaos.io. There's a getting started section here. I'm just going to select this command, which is going to help install the latest version on the 1.x branch, or 1.x series, 1.13.6, and it's going to create a namespace for Litmus, and it's going to place the operator there, and it's going to create the CRDs, the ones that we just saw in the slides, and it's going to create some cluster role and role binding and a service account that this operator is going to make use of. You could choose to use the same service account or have it good enough to run all your experiments, or you could choose to create per experiment service accounts depending on what kind of environment you run in, what kind of autonomy you exercise over your cluster. If you are in some kind of a self-service model where you would like the admin persona to put Litmus there, the operator there, an individual service owner or developers to run their own chaos, they can create their own service accounts. That's the model we're going to use right now. And the operator itself can be installed in a cluster-wide mode like we did now, or a namespace mode where it can work only within a particular namespace. That's also supported. Now that I've got, I'm just going to verify if my CRDs are there, my API resources are created. Sometimes on some clusters or on some distributions, it takes time for this API endpoints to be available. Now that we have them, my next step would be to pull the experiment CR from the Chaos Hub. I'm just going to pull them from the hub.litmuschaos.io, and I'm just doing a kubectl command here. I'm going to put it in namespace called Nginx, and I'm just going to put a lot of experiments here. I'm just going to do one experiment though. I hope my font size on this terminal is all right, and you're able to follow this.
It's good. It's good. Thank you.
All right. So I have an application pod. I just selected Nginx just because it's a popular Kubernetes deployment. So I have this pod which I'm going to try and kill. That's what we're going to do. And I already created this Nginx ahead of time. We have a note here that asks us to create a sample application. And I've already installed the experiment as I showed you. And my next step would be to create an RBAC for running this pod delete. I could choose to use a single service account that runs all experiments, or I could choose to use the Litmus service account that we just used for operator to also do the experiments by just augmenting it with a few more permissions, or I could just create a separate one. That's left to the user and the use case. So I have this RBAC file copied onto my harness machine. So I'm just going to go ahead and apply it. And that's going to create my service account in my Nginx namespace. I'm just going to confirm that. So this is what we have. And I'm also going to check whether I have the chaos experiments installed here. So I have this as well. Now we're going to define the chaos engine. The chaos engine is going to look like this. You can see that we are trying to do pod delete experiment or the fault against an application instance as defined by the label, namespace, and kind. There are a lot of options you can provide here. Auxiliary app info is just to see if you want to find out if some other application other than the one that you selected here is good and ready and healthy. Sometimes you want to do those checks on downstream applications. And you can provide the service account of your choice. We've selected the one that we just created. And the job cleanup policy is just to state whether you want to retain the chaos pods, the job essentially that ran the fault, or you can clean things up automatically. And then we have some env here. These are the overrides for the tunables we saw within the experiment CR. I want to do a few iterations of the kill. Sometimes may not be so meaningful, but this is just for illustration purposes. So this is the chaos engine. So typically you go ahead and create this chaos engine, and that should go ahead and trigger off your experiment. You will see that it is going to create some pods in the Nginx namespace. And you will be able to track the kill of the Nginx. So you saw that it's already killed. It's come up recently, but since we've given more than one iteration of pod delete, it's going to continue doing that for a few more times, and then it's going to complete it. And you could do similar chaos engines for a wide variety of faults, CPU hog, resource chaos like CPU or memory hog, or network suite of faults like loss, latency, or corruption, etc. You could eat up some disk space. You could do pod IO stress. You could do things at the node level. Node level resources can be eaten up. There are some very subtle differences between the pod and node level ones in terms of the way the resources are consumed, and also the use cases where they're employed. And you could also do things like draining your nodes, and you could put eviction taints and go ahead and move all the pods out of that node, something like an ungraceful kind of an HA. You could do restarts, you can do DNS errors, etc. So these are the kind of faults you could do with a very, very similar approach as to the one I showed. And now the experiment is completed. These pods continue to live here because we selected retain as the cleanup policy. And the chaos result can be checked here. The one that we're going to see is going to have very minimal information because we did not really define a very complex scenario. So I just have chaos result resource. This status portion is of interest to us. It basically said the phase of the experiment is completed and the experiment verdict is pass. So you may ask, on what condition did we call it pass? So right now, by default, Litmus is going to check whether the fault was injected successfully, and if the application that was subjected to the fault is ready and available after the fault ceased to be injected. So by saying ready and available, we are saying that the pod phase should be running and the containers listed within the pod should be ready. And once that is satisfied, we go ahead and say it is pass. But you can define complex conditions here, which we will see in later part of this demo, where you can look for custom conditions around K8s resources, or maybe some REST calls you want to make to check some health of applications, of downstream applications, or you might check some metrics that you are trying to get on Prometheus or some such observability mechanism, and use all that information to arrive at this pass or failure. And then you also have some history, and this is the resource that's actually going to be parsed or queried by the chaos exporter, which is another component which will provide Prometheus metrics around experiments. And this is the source for all that information, all the metrics that it generates. So this is what we had in 1.x. And what we try to provide is a declarative way of putting out your chaos intent. And Prithvi mentioned something about BYOC. You can create your own experiments, your own fault, wrap them up in an image, define that in a chaos experiment CR, and test it out as a job, and then get it orchestrated by Litmus. That's essentially how you would do the BYOC. And we have a declarative construct for defining chaos intent and gathering information about what happened during chaos, and basically make it simple to run chaos engineering for Kubernetes. But there are a lot of requirements on top of this that you would need, right? Let me go back to my slide deck to show you some of those things. I hope my slide is visible. Yes. So one of the things that we decided was, okay, all this is great, but faults, you need an ability to define complex faults, right? Standalone faults are great, but misfortune, when it happens, it doesn't happen singly. You have a lot of things going bad at different times. You would want to simulate those complex scenarios. So how do you do it? How do you stitch together faults? That is one thing. There's another thing Let's say you want to run some benchmark or load job or some performance test as you do chaos. And you would like to see what's happening under those stressful conditions. You don't want to inject chaos under idle utopian kind of cases, conditions of the app. You want to do it when there's active loads. How do you factor in, how do you weave those capabilities into an experiment? And then there is this need for visualizing chaos, not just running it, but you want to know what is running, how it is running, and what's happening as you run the experiment. We talked about observability, and observability is really important to derive benefit out of an experimentation process. You need to know what's happening when you run chaos, how the application is behaving. You need to be able to visualize that. You need the chaos framework to generate observability information and also consume observability information. Generate so that you can correlate the data with some observability that you already have set up around your application with infrastructure. You can map the observability data that you get from the framework with what you already have and say, okay, this is what's happening to my infra when chaos is happening. And the need for the framework to consume observability information is because you need to find out in an automated way whether your expectations were met or no. And how to find out whether your expectations were met? You take the help of some service level indicators, some of the observability data that you already have. So these are some requirements that we saw coming around chaos, and few other things such as, okay, this is great. I can go ahead and do chaos. I can install an operator, but let's say I have a need for centralized chaos management. I have several fleet of clusters and I want to do chaos against all of them and manage them centrally and also visualize what's happening with them, compare reports, chaos reports over a period of time, associate an experiment with some resiliency information that I can, some quantifiable resiliency metric that I can associate the experiment with, and thereby thereby associate with my application. So three-way association. You have your application or infra, you have your experiment or the fault, and then the resilience metric that relates these two. So your application or infra is resilient to this degree to this chaos workflow or this chaos scenario. So you want to be able to do that. So you want to weave in a more useful story that you can sort of use in your organization. All these requirements prompted us to come up with the next version of Litmus, called Litmus 2.x, which is an advanced beta right now. Beta 8 is what we have. And let me show through the demo of how we are achieving all that I mentioned. The basic topology is something like this. It has a portal. It also simplifies chaos through a UI for people who would like to use the dashboard. There's a portal and there are agents. So the agents are the ones that actually carry out chaos, and they speak to the portal and get information on what chaos to actually do and then go ahead and do it on your clusters. And you can connect or register your clusters to the portal, to a centralized portal through the agents, and get a single pane of glass management of all your chaos environments, so to say. And we also have Prometheus metrics that are collected from each of these clusters or namespaces, depending upon what kind of target you connect to your portal. You could connect either an entire cluster, which means the agent is in cluster mode, or you can connect a namespace, which means the agent is in namespace mode. And then you can collect some metrics. The agents collect some metrics around your experimentation, and it is going to derive those metrics from the chaos result resource and then populate it. And basically you can scrape it from Prometheus and instrument your Grafana dashboards to see what happens on your applications as chaos is happening. You could use Grafana annotations and things like that. And with this model of execution, we also started supporting chaos against non-K8s applications. So let's say you have a hybrid infrastructure where you have some legacy components, and then you also have some K8s services that you'd like to do chaos on. How do you do it? So with what we are trying to do here is we're trying to enable the experiments to mount config maps and mount secrets, etc., so that you can run the API provided by some cloud provider. You could use the AWS Go SDK or the Google Cloud SDK and go ahead and do out-of-band chaos against instances living on those clouds. In case you have a hybrid environment or you have some services residing on vanilla EC2 instances or GCP instances, you could run them from the portal. The experiments or jobs will run in Kubernetes, but the impact or the subject of chaos will still be outside, and we will be making use of the APIs provided by those providers to carry out this chaos. So these are some of the things that we can do. And this is just another schematic which is trying to reinforce the same thing. The architecture here is you have the Litmus portal, which is comprising of the GraphQL server. It has MongoDB to store chaos state of your workflows. Then you have the auth server. Then you have the agents sitting on your cluster. The green part here block represents the cluster where chaos is happening. Subscriber speaks to the Litmus portal and creates the chaos workflow resources. And this workflow resource, which essentially is an Argo workflow, embeds the Litmus chaos experiment chaos engine resources within it, and they are applied as part of individual steps within the workflow. And you could create chaos engines or chaos experiments. You could string them together in different orders, in parallel or in sequence, etc. When you apply that, the operator, which is also one of the installations that happens when you do the cluster registration along with the other agents, then takes care of reconciling this chaos engine. And the same process that we saw in the 1.x demo is going to play out. And then the result of this experiment is going to result in, it's going to influence the chaos workflow status. And that's something that's going to get reflected back on the portal. And you can also see its impact in Grafana through the Prometheus metrics. So that's what happens in 2.2. And before I proceed to a demo on my 2.x installation of the portal and how you can do chaos, I'll just pause for a minute and take some questions and do a quick time check if we can go on. Do we have time for that, Michael?
You can go on. I have time. I'm super curious what's coming next.
Awesome. Thank you. So I've just opened up the Litmus portal documentation here. It's in the Litmus README. The Litmus repo is Litmus chaos/Litmus, and I've gone inside the Litmus portal folder. I'm just selecting this particular command to install my Litmus beta. And before that, let me just go ahead and create namespace for Litmus and go ahead and apply the service. And as you can see, it has these control plane components that it has created. So I'm going to try and check by looking at the pods in Litmus namespace. The last time we did something similar on 1.x, you could see that we had just the Litmus operator. And this is the cluster on 1.x. I had just Litmus operator. I'm just going to close this now for ease of navigation. So we have the Litmus pods that are going to come up. And we also have the services which we are going to make use of. By default, it's going to use node port. Node port is not recommended for production. It's just for illustration purposes that we're using here. And I have a front-end service, the web UI, exposed at 30869. So let me just get my node IP. Sorry about that. So this is my IP, and I have a few browser tabs that I've opened here. Let me take a look at the port again. Let me open it. So it's going to take you through a very, very simple set of steps to configure the Litmus portal. Typically, you will be asked for some user information and you'll be asked to reset a password, things like that. I'm going to use the default credentials. And I'm going to keep this pods on this namespace in watch mode so that I can see what new things get installed as I proceed with my project setup. I have a little bit of a slow internet, So it's probably going to take some time to load. Just bear with me and give me a few more minutes. So once the portal is going to come up, we are going to set up a project. Each user is given his or her own organization or project within the Litmus portal, which is where you can actually invite some team members into. And when you set up the project, we have the cluster on which the portal is installed. That is this one, the GKE cluster where I have the portal installed, automatically register itself as a target of chaos. So the agents will get installed the moment you set up the project, which means you could start doing chaos against some applications that are already residing in this cluster. But you could also connect external agents into the Litmus portal using the Litmus CTL, which is a very useful CLI tool, which will help you to install agents on remote clusters and subscribe them to the portal. So let me go ahead and use the default credentials to log in into the Litmus portal. And once I get in, I just probably give the same password. Lit admin and Litmus is what it is. And once I get in, I will be able to take a look at the project dashboard. And you can see there are some tabs on the left-hand side. The workflow is the unit of execution of chaos in the Litmus portal. In Litmus 1.x, it was the chaos engine, which you're all aware of. The chaos engine is what we basically ask users to create. And while that remains to be the central piece, even in 2.x, we have by default the workflows that are going to be the overarching manifest that is going to do your chaos with all the dependencies baked in and a lot of faults together stitched in. You have the option also, you will have the option of creating a pure chaos engine using the portal without selecting an Argo workflow. That's something that's coming up in beta 9, which is an upcoming version of the beta. So going back, you can see I don't have any workflows right now. I can schedule one. And I have this chaos hub embedded inside the portal. You saw the chaos hub on the outside, but you have the same thing that's available here. So the same answer applies when you're doing Litmus 2.0 in air gap mode. You have the option of connecting what's called as a private chaos hub. You can create your own Git repository, the repository with all the YAMLs. You can provide that here. You can through access token or SSH, you can connect it and you can give a private hub that will get rendered here. And then you can pick that to construct your workflows, select faults for a given workflow. And you can see that there's an agent that's auto-magically registered. The self agent means the same cluster where the portal resides. And now you can see I have set up the watch. And apart from these three components which had been installed, you have few more. The exporter, the operator, the subscriber, the workflow controller, and then the event tracker. The workflow controller is going to basically reconcile the Argo workflows, and it's going to launch a set of pods that carry out individual steps within a workflow. And one of those steps will be to install the experiment and install the engine. And when you install the engine, the operator is going to reconcile it and carry out chaos. Exporter is going to provide metrics. And event tracker is something that is going to help you in doing event triggered chaos. That's something we'll hold for a later discussion. I don't want to probably bring in too many things here. So let me go ahead and also show you a few other things. You have an analytics tab.
Just one small question for the events. Do they use also Argo events then?
Great question. That's something we are looking at integrating. We don't have that yet. The event tracker is going to probably be the component that might get integrated with Argo events. So what we do with event tracker, I'll just give you a very brief overview is...
sorry.
No problem. It's basically to help you with triggering chaos experiments upon some custom events. So we've been manually triggering experiments here by running workflows or constructing them from the portal and running them or running them by hand, as you saw in the previous demo, etc. But sometimes you want chaos to be triggered in an automated fashion as a response to certain events that you see happen on your cluster. And we have an event tracker policy, which is a CR, which you can go ahead and define. Right now, it's configured to look for image changes. So let's say you have Argo CD or Flux that's actually upgrading your applications on your cluster as a result of your GitOps flow. And you want to check the sanity of your new change deployed onto your cluster. And the way you could do that is have this application subscribe to a predefined workflow that you have stored in Git. Your portal actually has this a thing called GitOps flag. There's a setting that you can do where you will have workflows created or constructed in the portal. If you have the GitOps enabled, it is going to get committed onto a Git repository. It will have a workflow ID. You could subscribe, that is the applications could subscribe to one such workflow that you have stored. And if you have an application change happening, image change to a particular tag or something like that, you could go ahead and the event tracker will go ahead and watch the applications for those changes. And if the change has happened, then it is going to trigger the workflow which has been subscribed to by that app. And you can track the progress of that workflow within the portal and analyze that here. So right now we are in the process of enriching what all policies you can fit into that event tracker. Just like image changes, there might be so many other things in the cluster that you want to do or trigger chaos in response to. And not only do you want to do it for GitOps flows, you might want to do it for non-GitOps flows as well. And the that's where we are looking at different kind of inputs or triggers for chaos. Argo events is a great one. We are thinking on those lines, but right now we don't have that yet.
Thank you.
Going ahead, let me create a workflow, and I want to explain a simple use case. I'm just going to show you two things with this workflow. I'm going to do a network loss just for variety and show you a very interesting use case. There is this Bank of Anthos application, which you might all be aware about. It's from Google Cloud Platform. It's a microservices application. And this is just to show you how simply you can construct an experiment from the portal and run it and see the impact of chaos. And once I do this, the next part of it would be to see how you can visualize the metrics of chaos. And for that, I'm going to use a potato head application. We're going to kill this. And I have set a black box exporter to check the availability and access latency of this particular service. I have a Grafana dashboard for it. And I have annotated it with some chaos annotations. And I'm going to run an experiment which is going to kill a single replica of this particular service. And it has been deployed with just one app replica. You're going to see the application basically change here. I hope my screen continues to stay shared. I might have just clicked something to disable share. Sorry about that. Yeah, so we will see this parameters changing on Grafana, and we'll also see interleaved dashboard. That is, we will have some area covered here by the chaos metrics. So before that, let me show you how you can run a simple experiment. The Bank of Anthos has some money here. I'm going to inject network loss or black hole attack against a balance reader service. So I cannot read my balance. Even if I deposit something, I cannot read what my balance is. These kind of scenarios do occur in real time sometimes. So to do that, I just click schedule a workflow, and I just go ahead and select a fault that I'm going to do. Just give it a few more minutes to load. As you can see, my
one question in the meantime. So when I with version 2, we have to use the portal, so it's like by default, or can I just insert the operator like in version 1?
You could continue to use it the same way as you did Litmus 1.
Okay.
The operator and the CRDs all remain the same. You could just consume just those components and install it and continue to work the way you consumed it earlier. This is something you could also do. Both are it's completely backward compatible.
I mean, for multi-cluster makes sense. Maybe for one cluster, the portal is maybe a little bit overdosed. I don't know. Oh.
Right.
Okay, thanks.
You could do both. So I just selected the cluster, the self agent. That's the same cluster where I have the Bank of Anthos as well as the portal. So let me go ahead and select next, and I'm just going to select my hub. There are different options. You could create a workflow from a predefined template that's sort of bound into the image, or you could clone an existing workflow and then reuse that template, or import a YAML file that you've constructed by hand, or you can select experiment and construct your workflow newly from the wizard. So I've just selected the public chaos hub that's embedded into the portal. And I'm just going to call it black hole bank of Anthos. And the workflow is going to run in Litmus namespace. And I'm just going to select an experiment. I'm going to select pod network loss. That's the one that we're going to do. And we're going to go ahead and tweak some tunables here. I just clicked on the experiment. And I'm just going to do next and see where I have my application. I have it in default namespace, and it's of kind deployment. And I'm trying to look what application I have. There is a deployment by this name, balance reader, that you can also see in the default namespace. That is the application here. This is the one. That's what we select. And I'm going to keep the cleanup policy as retain. I'm going to select next. And I can choose some probes. Probes is a concept which we will come to in a while. I'm just going to say finish. And with this, I'm going to take a look at how my YAML has been constructed. You can see this is the workflow. And it pulls the network loss experiment from the hub as one of the first steps. That is the first step. The second step is to install the engine. And the engine is defined like this. I've selected default application, app is balance reader, kind is deployment, and we're doing a pod network loss. And I'm going to do it for 60 seconds. I'm going to do 100% network loss, and I've just provided some socket paths and runtime details. And yeah, this is what I have. So it's making use of a service account called Litmus admin, which came by default when the agents were created. So this looks good. So I save it, and I have an option to revert chaos, that is remove all the chaos CRs created, but I'm just going to say false because I want to see the logs. And I go ahead next. So we were talking about this metric, right, in Litmus 2.0, the one that connects your application or service and the fault that you have been doing. So this is called the resilience score, and we can give some weight or points to a particular fault. And this is especially useful when you do multiple faults within a workflow. You can provide the criticality, and then what Litmus will do is it's going to multiply the points that you gave to an experiment with the success factor of the experiment, the probe success percentage, which we saw earlier. And it is going to get a summation of that for all the faults divided by the total points available. That's going to give you a resilience score. It's like a weighted average. That's going to tell you how resilient your application is to this overall scenario. So I just have one experiment. I'm just going to give all points to it. And I could do a recurring schedule, or I could do a single time schedule. So I just go ahead and finish, go ahead and apply it. So that's going to start it. We have a workflow visualization graph, which is going to tell you the progress of the workflow as it happens. And you will see some experiments that will get created in the Litmus namespace in order to carry out the experiment. There are some Bank of Anthos pods that will get created. So the first step, as you saw, was to pull the experiment, pod network loss experiment from the chaos hub. It's going to apply that. The next step would be to apply the chaos engine and launch the actual chaos process. So once this starts, and this is not yet created, which is why you basically see this, it's going to turn blue, which means it's going to start doing the network loss experiment. And once it starts doing that experiment, we will be able to go ahead and visualize some impact that will happen here. So let me go ahead and see whether my network loss has been applied or no. So it's still doing an init, it's pulling a new image. It's going to take a few seconds. So what we've done to the vanilla Argo workflows is we've instrumented it with some Litmus images to carry out these steps of creating the engine and tracking its status, waiting for its completion, etc. And these images understand the Litmus API, so they have been used within these workflows. So it's basically going to go ahead and create that. It's still doing an init. It's a fresh cluster that I've created, which does not have some of this images already. So it's probably going to take some time. Meanwhile, while this is happening, I could also probably just show you what probes are, why those are useful. And for that, I'm just going to show you a sample workflow that we have for Kafka, where we're doing a simple pod delete experiment, but we're going to kill the broker pod, which is handling the IO or the message stream, and that's going to trigger a failover. And in that process, we want to check the message stream continuing and not breaking. We also want to check other constraints, such as I should not have offline partitions, I should not have under-replicated partitions before and after chaos, etc. So some of that can be checked with probes. So just hold on to that thought. And let me take a look at why this is. So this is actual chaos. We have something happening because of which we are not able to it's going to give me a container. Okay, I think it finally started it. Took a very long time to pull it. It doesn't usually take this much time. Okay, so now that it is actually running, you will see some new experiment, the pods that get created. You have the pod network helper. Let me go to Bank of Anthos and let me refresh it. So let me sign in, and you will see I will not be able to read the balance inside this particular application. So you can see the balance is gone, which is dangerous. I can deposit some funds. Deposit goes through, but I cannot see the balance, which is not good. And I cannot send payments though, because make a payment, I need to check how much money is there in the bank. So the balance reader service is not accessible, so the payment fails. Some of these checks, for example, you could weave into the experiment as the probes. So going back, sorry for changing the context, but going back, if you take a look at this particular chaos engine that we are making use of within this workflow, so we have some checks that are inbuilt. There's something called as a prom probe that I'm doing here, where I have the Prometheus endpoint, I have a query which checks for under-replicated partitions, and I'm going to validate against a value called 0. This is my SLO or my cutoff. This is my SLI. You can think of it like that. And I am going to check at the edges, the beginning of chaos and after the end of chaos, that I don't have any under-replicated partitions, which is basically a check to say you leave your system in sane state and it has self-healed, auto-recovered, etc. And then there are also checks you would like to do through the chaos continuously. And there is a check we are doing for offline partitions, which is again through a prom probe with a different metric. You want to do this as you do the chaos. Sometimes there are negative checks you might want to do just for the chaos period and not through the experiment, which has all the pre-chaos, post-chaos phases, etc. So I'm going to check this consumer container, which is the one that's actually running this message stream that you saw. And I want this to always be available and ready, which means that there's been no exception. The failover has been successful. The message stream is continuing. So I'm just verifying the container status is true. And I'm doing this using a command probe. And there are also other probes like KTS probe and HTTP probe, which you can use to do REST calls, get or post requests, etc. And all this can be put inside of an experiment, and the chaos result that you get in such cases is probably more elaborate and gives you more information about what's happening in your experiment. These are very useful for automated runs. And this is what we meant by consuming observability information when we do the chaos experiment. Now coming back, so I think the Anthos, I assume, will have recovered because the chaos duration is over. It was just 60 seconds, so it's back. And the experiment has finished here. When you click this, you will be able to see the logs of the experiment and also be able to see some results here. And we didn't have any probes, so it just basically says the experiment passed and it's successful. So this is how we do chaos. And I could go ahead and run multiple such workflows and then go to analytics and see how this workflow ran over time, or compare this with another workflow, maybe another iteration of this workflow, to see whether the results were improving or they were decreasing, and you could get your resilience score as 100% here. Going ahead now, we'll show you the other aspect of chaos, and I'll probably end after this. This is about how you generate metrics as you do chaos. And you can see this, there is a chaos exporter that we are running, and which is getting some metrics. And I am going to actually create in the Litmus namespace a service monitor. I actually have a service monitor defined for the other components. The black box exporter is already defined. That's why you see this graph on a dashboard. I'm going to create one service monitor for the chaos exporter in the Litmus namespace. And let me just check if my Litmus services actually have the label. So it has the label called app is equal to chaos exporter. So in my service monitor, I'd like to select that. I have app called chaos monitor here instead of chaos exporter. So let me go ahead and fix this. Chaos exporter is what it is. And then I have this named as app chaos exporter, and added it already into my, sorry about that. I have already added it into my Prometheus CR. I'm using Kubernetes stack. So it's basically using a Prometheus operator. So app chaos exporter is what I have, and that's what we are going to provide here as well. TCP is the port name, and that's, I suppose, the name that we already have for my service as well. So let me go ahead and check if my port has been named. Yeah, I think yes, the port has been named as TCP. So let me go ahead and apply my service monitor. This will create a service monitor in Litmus namespace, which is where we have created it. It's already added to Prometheus. So now I should have the target on Prometheus. Let me check that. Let me go ahead and select the Prometheus service, which is in my monitoring namespace, and that is 31114. So it's basically the same IP on a different port. So let me open that. And once I have Prometheus, I'll go take a look at my targets. I'm going to check if there are Litmus metrics. Yeah, you do get Litmus metrics. You can basically check that in the targets as well. So now let me go ahead and do another chaos experiment, a very simple one. This time trying to delete this potato head replica. And for that, I'm going to use a very similar method. Select self agent. I'm going to select the my hub. So I'm going to select I'm just going to use some default name. Go ahead and add the pod delete experiment, and going to provide the right namespace here. And we have the namespace demo space, it's deployment. So app is hello service. And I'm just going to go ahead and say next and finish this. Going to turn off to see logs, provide the same schedule, etc. So this YAML is now going to look like this. So I have chaos engine, and you can see some of this extra metadata here, instance ID and context. A lot of this translate into, for example, the metric labels that you would see on the experiment. For example, the context and other things are all added here. You can see that you can filter by that. Context can be anything that you want to define. You might be doing experiments with a defined context in mind, so you can provide that. And we have the app labels and namespace and deployment for the hello pod. We're doing with Litmus admin, and I just want to do not too many iterations of chaos, just one iteration of chaos, but nevertheless, we can go ahead. And I'm just going to finish this. Let me go ahead and run chaos. This is going to show the creation of the experiment and then the actual pod. And let me go ahead and watch my pods in the demo namespace so that the potato service gets killed. Just have a single replica. It's a deliberate attempt to make sure that we lose this service for a while. I have not put multiple replicas. We're breaking things on purpose. So it's still pulling the experiment here. And now it's going to do the pod delete step. It's going to inject the pod delete chaos. And once you do that, it's going to go ahead and delete this pod. So that this is getting deleted, and at this point of time, let me go ahead and make this 5 seconds. So you can see that there is the success percentage that has dropped, access duration that has spiked, right? And Litmus Prometheus, we're trying to get some metrics, what's happening to this. So there is an awaited experiment, which is what now we are actually trying to show in Grafana. There should actually be a red area, the sort of starts up here. So if that's not appearing, then I need to take a look at what happened to my annotation, whether that is right or wrong. So let me take a look at whether the Litmus awaited chaos experiment it is, and chaos namespace is Litmus. Chaos result namespace is basically Litmus, and the job that I've provided is chaos monitor, but unfortunately that's not what we have. It's the chaos exporter. I think that's the difference. So let me go ahead and change this to chaos exporter, and the rest remains the same. So I'm just going to update this. I'm going to save my dashboard, and let me go back and take a look at my dashboard. So that should probably provide my interleaved dashboard. Let me take a look at something else is also needed. Space Litmus. Okay, there was a service monitor. That's again oversight. So I think the service also is called chaos exporter here. All right. Now I hope things will work. And going back to my dashboard. Yeah, so you see this red area, and I think this is probably not very visible with the white dark background. So let me change the preferences to make it light mode. And just give it Grafana a second. All right, now let me go to my dashboard. Yeah, and now you can actually see chaos happening. So this period is when chaos actually occurred. And you could also use other metrics to give you the verdict also on Grafana if you so intend. But this is the period when the chaos actually happened, and you can see that the availability dropped, access duration spiked, and then it recovered, right? So the hello services, I'm sure it's going to be back anyways. But this is how you can sort of use the observability data generated by the framework, the chaos framework, and instrument your application dashboards with that, and then basically get a closer look get a better idea of what's happening. You can even run this automated and see this later. So that gives you an idea of how things have run. So this was the other aspect that I wanted to show, and we've also covered the probes, so which is pretty much what 2.0 is all about. And now, just to recap what we were talking at the beginning of this session about these principles that Litmus follows. So we talked about being open source and community collaborated. So without the community getting involved, you cannot have a rich library of experiments and scenarios, which is why we believe that cloud native chaos should be open source and community collaborated. Open API and lifecycle, you took a look at the chaos engine and the experiment and the result. CRDs are themselves APIs, and using the BYOC approach, the bring your own chaos approach that we enable with the chaos experiment CRs, you can write your experiment in a standardized way and have a standard structure of orchestrating it as well, which makes it easy for people to come and contribute their own off-the-shelf experiments, but still have a defined way or expected way of going about it and how they can operationalize it. GitOps is the event tracker story we just discussed some time back. And then open observability is about being able to generate metrics, consume metrics, and have a standard for how you can speak to existing observability infrastructure, open source observability infrastructure, and leverage that within your chaos experimentation process. So these are the principles that we thought we should inculcate into the platform as we were building it out. And that's what Litmus is all about. And with that, I'm concluding the presentation. Thank you so much for giving us so much time and being patient through this process. And I think there was a contribution aspect which we probably missed out on, but there's a link that I've shared to the SDK. You could contribute new experiments using that tool to just bootstrap new experiments and fill in your business logic and share it. Or you could also contribute to documentation, or docs are really welcome. That's one area that we're really seeking help on. And also to the infrastructure components of the portal, control plane, operator, etc. So these are the areas which you can collaborate on. And Prithvi will share some information on where you can join the community and how you can sync up with us. There are some monthly sync up calls and meetups that happen. We do a monthly release on 15th for both beta of 2.x as well as 1.x. So feel free to be tuned in on that, and yeah, hope we can help the community with their resilience needs and get going with chaos.
Thank you so much. To be honest, I'm now like flooded with ideas what I want to try out immediately. I think one of the contributions could also be, you've talked a lot about GitOps workflows and Argo and Flux. There are potentially other tools around that. So like combining it with GitLab CI/CD or any specific other integrations then. And not only writing a blog post or a tutorial around it, but also provide demo repositories, provide the insights in either session with us.
It's a great question.
Everyone is in. It was basically a proposal to do it, because the more different tools and different environments we can gather, we can like get an idea about, the more like popular Litmus Chaos will get. And it's also like a diverse setting of saying, hey, does it work in that scenario, or do we need to add a certain, I don't know, feature code thing to actually enable everyone to follow the chaos engineering workflow.
That's a great thought, Michael. That's something that we would like to do. Definitely, there's some integrations with other tools, notably CI/CD tools that are there. Let me just share my screen to show you what is already there. It's a little bit rudimentary, but it's more on the 1.x side of things. So we have what we call as GitLab remote templates. So if you have a GitLab CI.yaml and you are running your own stuff in your pipelines and want to introduce a chaos stage or as a resiliency test into it, you could make use of some of these templates that we have already. You could just, GitLab has an amazing feature where you could import templates, remote templates, and you could just import this and override some of these variables from the GitLab CA.YAML and get the experiment done. So this is going to actually pull Litmus. There's also actually another flag called Litmus install true or false. And you can actually install Litmus, run the experiment against the app of your choice, and get the GitLab job pass or fail based on the chaos result. The success of the GitLab job depends upon the chaos result verdict. That can be done with the GitLab templates. And we also have some integration with Captain, where there's a control plane service called Litmus service that runs in the Captain control plane. And you can add chaos stages within a Captain pipeline. And you could basically do this with load generation that Captain naturally allows. You can do JMeter or locus tests on your application, and then you could also use Captain's quality gate feature. By using Litmus experiments, you're making a more stringent assessment of your application resilience, load, chaos, etc. And then you can set your SLI and SLOs, and depending on that, your quality gates will enable you to promote or roll back your applications. And there's also an auto remediation use case that we're exploring with Captain, where Litmus can be used as a sanity test and as a remediation verification step. So some of these integrations are going on, especially in the CI/CD space. Another space where we would really like to integrate and get better at is the observability platforms. Prometheus is great, it's very common, and it's probably the most used one. Similarly, there are other platforms, cloud native platforms we would like to hook into and enable people to sort of get their Litmus experiment details onto their own app dashboards and APM environments. So these are some of the integrations we're looking at. And there are also other, I wouldn't call it integrations, but collaborations that are happening with teams like Pravega, which is another CNCF sandbox project, Strimzy, which is a Kafka CNCF project, another sandbox project, where we're trying to enable them to run chaos experiments for testing out those projects as well. Pravega has in fact been using us for nearly a year now for their E2E tests. So these are some of the things that we have been doing on the community front, on the integration front, within the larger context of the cloud native ecosystem. We'd like to continue doing that and be more engaged with the community and make it a tool that is going to help shipping other tools. That's the intention. And we're also trying to dog food some of our own templates and scripts for Litmus Litmus components itself. Some of the faults are being injected against Litmus components. So these are some of the directions that we are going into, trying to provide some documentation around all these things, which is now missing, to be honest. It's something that we need to go ahead and add in the days to come before we sort of go ahead and do GA of 2.0. And that's where we're also trying to seek some contributions on from industry folks. So yeah, that's what's going on, Michael.
This is really great. To be honest, I just pinged everyone on Twitter to try it out and shared all the things you shared, like reverse engineering your screen share. Yeah, I would say potentially we will try it out. Well, I will definitely try it out, and especially the observability parts and integrating it into the existing Kubernetes cluster and the monitoring stack and the Prometheus operator. I think this is a really great and nifty idea. And also I admire your passion of presenting that. I just wanted to say that out loud. I also tweeted it. And the other thing is, I really like the UX. This is like you have a wizard, you have workflows, you have immediate feedback, you get the logs, you get the chaos results. So this is, I think it's a really great first impression when you start it, and you can keep going. So I think this will definitely be one of the you want to stay in the UI, and I think that's really great what you have created, what you have designed. So thanks for your passion and also for your open source spirit. And I don't know, Philip, do you have any other questions around? I guess.
Yes, sure. Just two. One technical. When I use the UX and the portal, okay, how can I make it like declarative? Because, like, for example, let's say I migrate my management cluster from A to B, and I don't want to click to the UI again to create all those experiments. Is there something like I think you use MongoDB, as I saw, for persistence, or in the background as a backend? Is it like, can I export it? Can I don't know. Yeah. How would I add the declarative way with the UX, basically, to make it short?
That's a great question. MongoDB, you're right. That's what we use to store the details of the experiments. And there is something that's downloadable or exportable today in a way. Let me probably also share that.
I mean, it's beta, it's okay. I mean, so everything is good. Just wanted to ask.
Right. So there is the section called Workflow Dashboards in Analytics, where you could compare experiments. You could take a look at how it's done, and then you could download stuff. Basically, that's something you could do. We have PDF now and some other report types being supported. That's how you can get information. But as regards a declarative way of using 2.0 or the portal, which is a great question. The workflows or the intent of the scenario, the chaos intent and the hypothesis intent, all that is declarative, as in it's a mixture, if you see, of being declarative and imperative. Argo is reconciled, the workflow, and the chaos engine is reconciled. But both Argo workflows as well as Litmus chaos experiment CR allow you to define what you want to run, and it could be imperative to a degree within those manifests. And it's sort of a good mix of both. We are also having some features coming in to manage the status of these tests when, let's say, when the pods are evicted or jobs are lost and things like that. We'll still be able to reconcile, we'll be able to clean things up without leaving orphan resources. All that is something that's there to a degree and is also being added. And we kept it this way to support both modes of usage. As regards how you can run portal without the dashboard, if that was the question, you could do that with APIs. There are some GraphQL APIs which we are documenting and will expose shortly to the community, and you could start using that. And you could write some scripts around the day 0 and day 1 operation that you want to do on the portal. Things like connecting agents and creating workflows or triggering schedules, downloading reports, all that is something that you could do. Okay. But most of whatever is defined as YAML and whatever is mostly the Git stored component of the portal would be the workflows. Of course, the portal itself is a deployment and a stateful set, etc. The Mongo, you could use Argo CD or something like that to manage its life cycle, but the experiment life cycle is mostly residing within the workflow. Did that sort of answer, Philip?
Yes, all good. Thanks. And my second question is more like general. I mean, as you said, you started 2018 around with this, let's say, movement. Yeah. How is it like? I mean, chaos engineering, to be honest, is like showing your for example. Okay, let's start different. When I have enough trust to run chaos engineering in production, yeah, basically it's like a sign of weakness in my work to my boss. You know, how you can pick up those people to engage in chaos engineering, because we are humans. We are not people who want to show weaknesses in a team to our boss. Let's say, hey, your work is bad because your pod is, when it's restarted, then your work is bad. You know, so how can we all together, like pick up those people to engage more in chaos engineering and more in resilience. So how is your experience there? Basically, let's say the question.
It's a great question. It's in fact a very one of the initial big challenges that we faced was exactly on this count. It's a culture thing, like Prithvi also alluded to earlier. People don't want to do chaos because, like you said, humans, we don't want to show weaknesses and we don't want to disturb what's already running and good. There's also this, there are other inhibitors to adoption of chaos. One is the lack of a proper observability infrastructure. Sometimes teams are in the initial stages of setting up microservices environments and all that, and they do not have the right tools in place to see what's happening when they do chaos. So they feel that lack of control, and they are basically very reluctant to go and do chaos because they don't know how to remediate, when to step in, things like that. So observability goes hand in hand with chaos and is a real prerequisite. And the other thing is, though doing chaos in production is really the nirvana, so to say, of mature chaos engineering practice, the pinnacle of chaos discipline within an organization, there are not so many people who do it in production. They want to do it in staging environments, pre-prod environments, dev clusters, etc. And one of the things that, like you say, who are the people to pick? What are the right people to target? What is the lowest entry barrier teams to take for chaos? And the observability teams are the ones that will probably jump onto this first, because while you don't want to disturb your main business applications, you don't want to basically go ahead and disturb what's running well, you will still be okay to kill some observability systems or some services you are using for monitoring to see if you're getting the right reports and notifications and alerts of your main application, and your observability is highly available or not. Let's say you have Prometheus and you just have a single replica of Prometheus deployment, and you went and did a pod delete or network failure there. You would still want to know how your end service is behaving. You would want to get the right alerts and notifications. You want to see the graphs there. Is that still happening when your monitoring framework is getting subjected to some kind of faults or no? So that is a good service to target, and the team that works on observability is a good one, or good adopter of chaos upfront, which is what we have seen in our community as well. And then they slowly gain confidence from it. They pitch that to the other teams, the service teams, and then they go ahead and do chaos, and then it sort of becomes a movement with which everyone becomes comfortable at some point. So that is one easy way of pushing things. And another way of doing it is to start in dev clusters. It's like even in dev test. When I say dev testing, I'm talking about the ones that the QA teams are doing, because we also need to sell it to the QA teams sometimes. They have their own test plans and they have their own schedules, and this comes in as sort of an additional thing. So you could even do it, developers themselves could do it in the sandbox environments that they have, where they do their initial tests before they push off code into their CI/CD pipelines or into the QA teams. That is also another place where they could do chaos and show the value. Maybe they might not use the same kind of data sets, or they might not have the same kind of SLOs that they would eventually have in staging of prod environments, but still they can do faults and weed out those initial issues that will appear or that may appear, and then show the usefulness of this practice to the other teams. Then they can catch on, the QA teams then can catch on, and they can do a lot. One of the huge consumers of chaos in the last few months, as we see in the Litmus community, have been the QA teams. Not only the traditional ops, SRE teams, who we generally associate with chaos engineering. Of course, the persona is there, but what we see are a lot of QA people trying to do failure testing with a chaos mindset, with this exploratory mindset that is associated with chaos experimentation. They have also been doing it. So these are probably some of the methods where you can inject the discipline into an org and then sort of make it a movement.
Yeah, I think always, like, I mean, if you have pre-prod and staging and tests, it's all good. Yeah, you need this definitely. but I mean, at the end, in staging, in pre-prod, you never have the production workload. Okay, so you never have one-on-one the situation which you have in production. And I'm the kind of like, I would rather have a planned, I don't know, half window of maintenance announced, hey, we do maintenance, and then run our cars experiment in production, then have, I don't know, some unplanned outage, which can, I don't know, nobody knows of, and then you know how it is, SRE, in the night, the Kubernetes cluster goes down, then you have the unplanned work. I mean, if we refer to the DevOps handbook, the unplanned work is the worst work. Yeah, I think hopefully it will grow the chaos movement.
Yeah. Some of the really mature ones do it. AWS, Netflix, these are the pioneers, the people who constructed the initial manifesto or principles of chaos. They do the game days. That's a very popular concept where, like you said, they plan the outage time, they get all stakeholders involved, get a buy-off, have all mitigation plans ready, they go inject it, they note down observations, and they share findings, and then they repeat it. Because, like you said, nothing can simulate production. The dynamic nature of the production environment. That's true. I think slowly it should build up to that point where people are comfortable running chaos in production. They should have tested it enough. And also the framework that they're using should probably enable them to do that, give them that feeling of control. For example, one of the features in Litmus that we've added in recent times is called as the dead man's switch, or the automated rollback, where let's say you have a Prometheus probe defined to say you're exceeding a certain metric, certain threshold of a certain metric, which means things are getting out of hand. You need to stop. You can immediately patch the engine to abort. It automatically stops the experiment, and then you and then you can specify blast radius in a very controlled way. Apart from just the labels and namespaces we gave, you can use annotations to say, amongst the so many deployments in this namespace with this particular label, choose or zero in on just one particular deployment, or maybe one specific pod or something like that. So you could do this blast radius control, do the right hypothesis, the ability to abort, the ability to schedule at a specific time when you know the traffic is less, things like that. These are all enablers that you could add from the framework side to get people to run it more in production in a more confident way. So that's been our endeavor as well. We've been trying to think in those lines also.
Okay, thanks a lot. I mean, yeah, short you said, start with your observability stack, gain some confidence, and then go to prod. Basically. Easy.
You mentioned before that Kubernetes is not a dependency. Did I understand that correctly? So you're also targeting AWS or something else?
Yes. So you do have experiments that can terminate EC2 instances or detach EBS disks, whether they're like just disks attached or maybe they're mounted as PBs. And we also have recently introduced experiments that can do not just these out-of-band kind of things, using APIs of AWS to kill instances or detach disks, but you can also go inside an instance and simulate some resource hog or latency, network latency and stuff like that. So the experiment will still run in Kubernetes. The chaos engine is going to look very similar to the way you saw how pod delete was defined, but you will have some secrets created or IAM roles mapped within the experiment, and you will use that to go ahead and do the chaos against the cloud resources over the network. But the control plane and the experiment plane, the execution plane will still be on Kubernetes, but you're targeting entities which are not really Kubernetes. They're like the infra components, maybe vanilla EC2 instances or GCP instances. You could do that as well, because a lot of people run hybrid environments and they're not completely migrated into Kubernetes. They have some services here, and some services living in legacy infrastructure, and they want the same tool set or platform to be able to orchestrate chaos on all these things. So that's also a requirement that we got, and we sort of enabled that in recent times. So Same goes for bare metal systems as well. In fact, there are experiments that we are going to add, or we've been working on, where you can use IPMI APIs to sort of do out of band power off, power on stuff of machines, like some, for example, Dell machines provide iDRAC capability, and they give you APIs, so you can do things there. So these are things you could do while retaining a common experience, homogeneous experience on Kubernetes, engines, declarative, store it on Git, etc. But do chaos against a wide variety of infrastructure around you.
Thanks. That's really great to hear. I also get some, or like from my own experience, I often get like Kubernetes is like hard to get into, and I experienced that myself. So the learning curve is like, wow. When you're into it, it's like, oh, it's amazing, and I'm totally into it. So like when I want to start as a developer, or maybe as a DevOps engineer, whatever the role title is, you potentially want to hide the Kubernetes component and just say, hey, here, execute something, or this is like the steps. And you maybe have a Kubernetes cluster, or it's just something else. And the entry barrier is not that, oh, there's Kubernetes, I'm not using it. Because I think right now the messaging on the website is also a chaos engineering for your Kubernetes or Kubernetes cluster. This could also be opened up when you have like a directional roadmap where you say, okay, our potential target groups are Kubernetes, 90%, but we're also moving into, like you said, hardware, bare metal, or specific hyperclouds, or the small cloud providers, anything which can be tested. Maybe even going into IoT, or I don't really know what edge is, but all the new stuff which potentially has some, you don't have any competitors inside because there is no chaos engineering yet. There's potentially some unit testing or extreme testing somehow, but like finding in or putting in the chaos in production is something where sitting there and saying, how should I do that? I have no idea. And having a framework and having a tool stack around that makes that super easy. And especially since you're also focusing on the declarative way of having a specification, it's easier to sell it internally to your teams, to your managers, to your groups, and say, okay, this is a proven standard. Everyone is using that. We can rely on that, and we can invest on in our product, in our infrastructure, and adopt Litmus Chaos, for example, or Litmus in that specific sense. And I think that's a really great idea, and I will talk to our product managers and also to our teams around this and see how far we can get, or maybe even like work in a similar fashion as we tried with the Captain project, just to collaborate even more and see where we are going, and can build a great cloud native or even more chaos engineering idea or collaboration around that. That would be amazing.
Awesome. That would be just fantastic. Thank you for that, Michael. I think you summarized it very well. Yeah, we have seen some interesting use cases in the community around chaos. Some of the end users' stories are very fascinating. And there's some good discoveries made as a result of chaos, which we are also trying to sort of get them to speak on some forums like this, or go to CNCF and basically talk about some of the very interesting use cases that they have, so that the community at large is benefited by those insights. So hopefully we will see more sort of information and more awareness. And chaos engineering has been there over a decade. It's really gathered pace in the last, I would say, couple of years. Accelerated in no small part because of all this cloud native paradigm and digital transformation journey people are making, migration to Kubernetes, microservices. Within the process was always there, but the tooling around it and the awareness around it has sort of become increased. Prithvi was mentioning about how CNCF, the team at CNCF feels that this is also a trending technology, and hopefully there's a lot more innovation that comes out of the community in this area, and hopefully Litmus also improves and proves to be useful to a lot of folks.
And I also submitted some CFPs for later this year with Chaos Engineering inside. I knew that I needed to look into Litmus, so I'm really grateful that you took the time today to educate us or to show us what is hot or what is new, especially. I would love to have you back, like, I don't know, in half a year or something, when 2.0 is released, or 2.x. And we'll have some more use cases, and maybe we'll have deeper collaboration or something around that. Other than that, I really appreciate you taking the time. I know it's late for you. So we kind of extended it to 125 minutes now, but it's totally fine. I was very much enjoying it. And yeah, thanks to you, colleague, and Prithvi for joining today. And I would just say bye-bye on YouTube. Thanks for listening. Blog post will be published later on.